Okay, next we're going to talk about how to solve Cauchy-Euler equation. And the first case is with distinct real roots. So Cauchy-Euler equation will look something like this. So kind of you have these like variable t in front of the derivatives. So then I think in the formula we know that this 2 is a, and I think this is b. And remember in the kind of the first half of this section, we have this r equation, right, where you just put the coefficients in front of the r, like correspondingly. But now with the Cauchy-Euler, the only thing that changes is that instead of just having a, we will have a minus 1. So instead of just 2, we will subtract 1 here. So that's r, and everything else should be the same. Okay, so if you're interested in why this is the case, you should take a look at the lecture notes. There's some like derivation of the formula, but in this video we're just gonna kind of memorize what to do. So just everything else you still kind of just write down the coefficient, except this a, you subtract 1 from it. So really you're solving r squared plus r minus 12, and then that's r minus 3 plus 4. So then one is 3, the other is negative 4. And then the general solution will look something like this. So general solution is y equal to c1. Now we don't have the exponential. In the Cauchy-Euler, we have t to the whatever the root is. So t to the 3 plus c2 t to the negative 3. And there's no variable here. You just put the root as the exponent. And that's all. That's how you write down the general solution. And of course, I can also give you some initial conditions. So for example, if I also give you, y1 is 0, y prime of 1 is 6. And then you can use these two conditions to solve for c1, c2. But I think I'm gonna stop here for this. So kind of you should have this a clear idea, kind of an algorithm of like what to do. But the rest of it should be pretty easy. You just take a derivative and then plug in these two equations, and then you will solve for c1 and c2. Okay.